Now that we have started OpenOCD and GDB, it's time to do some debugging. In this lecture, I will demonstrate some of the most useful GDB commands and workflows. I will show you how to inspect and set variables, create breakpoints, step over and into the code, inspect the stack. I will also show you how to use the enhanced GUI version of the GDB interface. Let's begin. I usually start by resetting everything, so starting with a clean slate, I suppose. I can do this command, you can say monitor reset init, and that will initialize the sketch running on the board. This is basically the same as pressing the reset button on the board. It will start it from the very beginning. Okay, and it's halted as well. Instead of using the full monitor command, I can just say monit. So if I say something like monit and reset and hold, this is going to stop it, and you can see that the execution of the sketch has stopped and there's no activity on the LEDs. I can type in cont or just C to restart the execution, so the LEDs are out there blinking again. There are no breakpoints assigned, so if I'd say C, hit enter, then the sketch will continue running indefinitely. If I want to stop it in order to interact with it, then I can do a Control C, and I can go then back to my command prompt, and GDB will wait for instructions. Let's have a look at some of the code that is running. So I can use the L command. Think of it as list, so the L command, and type in something like a number, and that will take me to the part of the compile code that I have indicated with the number that represents the line. So I asked for line 15. GDB gave me line 15. If I want to be a bit more specific, I can say to GDB that I would like to have a look at my loop function. So just name the function, and GDB will show me the code, or at least a part of the code in that function. I'm going to show you later how you can run GDB using a GUI-like interface. It's still going to be in the command prompt, but it's going to give you a little bit more browsing capability. But I want to just show you the clean, the bare minimum GDB interface first. Before I set breakpoints, let's say that I'd like to inspect the value stored in certain variables. So to do that, I can use the print command and say, for example, print counter, and that will tell me that counter, the variable counter right now has got the value 18 stored in it. Or what about the value stored in LED1? So LED1 contains value 3. And of course, I can make changes to those variables. I can set, for example, I can set counter to a different value. Let's make it 10. Okay, print counter again. It's 10. So this is how you can manipulate variables while your application is running. So I can say C to continue, and they're off again using my new values. I can also interrogate my running application and ask for information about variables. For example, I can say info var counter, and that will tell me that I've got a variable called counter that is an integer. Let's set a breakpoint now. So let's have another look at the loop function, and then I would like to set a breakpoint on line 31. So I can just say B, or you can type in the whole word breakpoint, and you can say 31, and that will now set a breakpoint to line 31. You can get information about breakpoints by saying info breakpoint. breakpoints. Right, so I've got one breakpoint, so numerical one breakpoint inside loop at line 31. So it will give me the whole path to the source code of the program that I'm debugging and tell me which line has the breakpoint on it. Alright, so with the breakpoint set, I can continue the execution and the program will start and then stop as soon as it hits line 31. And then here I can get information about the state of the variables, for example. It will tell me that now it's gone up to 15. I can then choose to continue one instruction at a time, just like I did in Atmel Studio. So I can use the N instruction, and that will go ahead and execute one line at a time. One line at a time. It's one line in my sketch. But it will not drill into functions. So you can see, for example, here it hit the instruction delay, and then I hit N again and it moved to the next line in the program, but it did not drill into the function. If I want to drill into the function, then I can use the S command. And you can see here that now I hit another delay. So I hit this delay instruction, and because I hit S, my debugger jumped into the file that implements the delay function and is now waiting in line 65. So I can continue with this stepping into, and now I'm just drilling into the inner depths of the Arduino dependencies, now moved into the hooks file, which suppose implements the yield function. And an interesting thing to do while I'm this deep into the execution is to have a look at the backtrace. You can use the command backtrace or BT and have a look at your present location in the stack, in the execution stack. So what you see here is that first, when I started my program, I executed code that is found in source file main.cpp. Then on it, I executed the program that is found in my own sketch, in my zero debugging example.ino sketch. And then as I continued, I went down one more level stack in the stack that exists in the delay.c source code file. And then it called yet one more level on my stack that is implemented in the hooks.c file. So my stack right now is 4 levels deep. So using the backtrace is a very good way to discover what goes on in the background when a sketch executes. So to resurface, I'll use N a few times. It will take me back up to the level, the stack level of my own sketch. Or if I'm pretty deep, so instead of doing that, I can actually use a command up and say go up one level, and you can see that now I've moved into my own sketch at zerodebugging.ino. So this allows you can say up or down depending on how deep in the stack you want to go in your debugging session. Of course, I can use C to restart the execution until it hits the next breakpoint again, or I can be a bit more explicit and I can say continue and bypass a breakpoint 10 times. So C with the numerical 10, that will allow me to execute the sketch until in total 10 breakpoints have been encountered, and then the execution will stop once 10 breakpoints have been encountered. There you go. I know that there are a lot of commands here to remember. they do become muscle memory sooner or later, but a very good resource for you to look at and print out and keep handy is this GDB quick reference guide. It's a very good material. Just print it out and keep it handy. It will really help you with starting to learn and remember the various GDB commands. So that was a quick demonstration of the kind of commands you can use with GDB, but there is one more thing that I'd like to show you. I'm going to quit, and then I'm going to relaunch GDB, but this time I'm going to set the TUI flag, so that will start GDB with what's called the GUI version of the user interface. So there's this box up here that allows me to always have access to the source code of my executing program without having to use the L command to print out the source that I'm interested in interacting with. The process once you start GDB this way is the same. First, you will have to load the EMF file. So I'm going to copy it again from my text editor and paste it in here. So loaded the program, and now you can see that up in the GUI box, if I can call it that, you have your source code. Of course, this is the main function. It's the function of the Arduino program that you never really see when you are coding in the Arduino IDE, but it sits there in the background, and it's the code that will call your init, you call your setup functions, and then it will call your loop function in your actual source code. Okay, from here, down in the command line area of the GDB GUI version, I can use the exact same commands as in my previous example. If I would like to look at the loop function of my program, just say L loop, and then in the GUI part of the GDB, you'll be able to see the loop function of your program. The arrow keys that I'm pressing now, I'm just pressing the arrow keys on my keyboard, always automatically have focus on the GUI part of the GDB client. So you don't have to press anything or do anything else to be able to navigate up and down with the arrow keys. Of course, you can use L to go to a line of code. So I can say L go to line 50, and the GUI part of GDB will respond and take me to line 50. So everything here works. So I can say C to continue. Oh, I haven't started running, of course. So let's start it. Let's say first I will reset it. So I'll say reset, hold. All right. Oh, sorry, my mistake. I haven't connected yet. That's why. So what I've done is I have loaded the sketch, but I haven't connected to OpenOCD. So you can see here in my OpenOCD window, the last thing that I've done was to drop the connection from a previous GDB instance. So there's nothing connected to OpenOCD anymore. So let's connect before we continue. So target remote localhost connect to port 3333. Okay. And OpenOCD confirms that it has accepted a new connection, TCP port 3333. And now in the GUI part of GDB, you can see a little arrow indicating the location of the sketch right now. So continue. And there you go, it's running. I can set breakpoints. I can set a break. Actually, let's say it's moved to delay. I'd like to go back to the loop function, and then in the loop function I'd like to set a breakpoint again to or onto line 31. Okay, so let's continue. It will continue from the location where I stopped execution when I hit Ctrl+C on my keyboard. So from this point where the program is presently sitting at, I will continue. So C, and there you go. It stopped at the breakpoint line that I prescribed earlier. And everything else will work. So I can go to the next instruction. So this is stepping over. If I want to step into, I'll use the S instruction or S command, and that steps into. So yield, and then they will drill into the next stack level. So now it's at the source code for file hooks.c. And keep going. Yield again, so back in hooks.c, then back delay. I can check on, I can have a look at the backtrace. So I'm at 3 levels deep at the moment inside main, and then loop, and then the delay function. Next, and continue. GDB has got a built-in help system, so you can just say help and find more information about the various commands that are available. So for example, if you want to know more about the backtrace command, then you just type, quit. Okay, so you can just type help backtrace bt. So backtrace of all stack frames, etc. Okay, so there was an introduction on how to use OpenOCD with the GDB debugger. It's, I think, a tool worth learning because of its flexibility, the fact that you can find it everywhere, and of course the Arduino IDE already has everything you need to take advantage of these two utilities. In the lecture notes, you'll find more resources that will help you with getting started and learning the more intricate use cases of these tools. But as with everything, the more time you spend using them, the better you get with them.